Hello, Stephen here. Today I'll be putting together a video discussing using the hub motors in the Mark IV drives for Michael Baddeley. Most of this video will be common no matter what control system you go for. However, this will also be discussing the use of Padawan360 for controlling the speed. So what we have here is we have a hub motor and a Flipsky ESC. This is the mini VESC ESC 6.7 Pro that I've got here. So I'll show you what's in the bag and get the bag out of the way since it's quite reflective. Okay, in the bag you get your ESC obviously, and connect the harness and a USB cable, which I guess you can use for the programming. On the hub side, we just have very simply a hub motor and a cable which is maybe a meter long. So with that meter length of cable, in theory you could take the wire all the way up the leg of your droid and have the ESC in the body. What I've done though is I've trimmed the length of this cable down quite dramatically, and I have the ESC mounted in the battery box of my droid. I've seen a couple of varieties of connectors coming with this. I have received other hub drives where all of these smaller wires are on a connector block. I just cut those off because I'll be rewiring them anyway. And these slightly larger wires there for the 3 phases of the power out of the ESC. You'll see with the ESC, you have power in, red and black, obviously, and then you have 3 phases out, which go to these 3 phases here. For connectors, I've used this style of pull-apart connector. It's in line, very nice and tight fit. However, you do need to make sure that you insulate them very well. I've used heat shrink on mine, and I'd suggest even a bit of electrical tape over the top of those afterwards, just to make sure you are going to get no shorts whatsoever. And I've used the same connectors on this end as well, which makes it easier for pushing wires through small holes. Okay. As well as the power in and power out, on the ESC you also have a what looks like a servo connector. This would normally be plugged into a channel on your receiver. However, because I'm using Padawan, it will be plugged into an Arduino Mega ADK, and I'll go through that in a while. On the wiring of the hub motor, you've got 3 phases. It doesn't matter which phases you connect it to on the ESC. The only difference is the motor will reverse. You can change the motor direction either in the software or just take two of the phases, swap them over, and that will reverse the direction of the motor. Only do that before you've finalized the programming of the ESC though. As well, you've got these smaller control wires. You've got a black and a red. Unsurprisingly, that is a 5-volt and a ground. And then you've got 3 colored wires, a blue, green, and yellow. These are for the hall sensors within the hub motor. And if I change over to this, you'll see that the ESC has a number of connectors. The connector we're interested in is connector 2. That is the connector that this wiring harness fits on. And I'll just split the plastic here to get in. Wiring harness for connector 2. Here you will spot that we have the red and the black for 5 volts and ground. There are H1, H2 and H3, which are the hall sensor connectors. And then there is a white wire as well, which is for a temperature sensor if that's fitted to the motor. The motors we're using, they don't actually have a temperature sensor, so we will ignore that. The connector, I believe you can get connectors to mate onto this. In my case, I didn't. I just cut these wires and then soldered them to the corresponding wires on this side as well. Red and black, very obvious. The hall sensors, again, it doesn't matter which order you do them in, but I connected the yellow wire to the yellow wire, green wire to the green wire, and then because there is no corresponding blue wire on the ESC, I've wired the orange to the blue. So that gives me all the hall sensors connected, the 5 volts, the ground, and the 3 phases connected. Power in, I'll be using a 18 volt Ryobi battery, and on any ESC, please make sure you put a suitable fuse on the power input as well. We don't want any accidents with these things. I can show you now how I have my system wired up. As I said, I've got these plug-in connectors, nicely insulated. So if I need to change the ESC for any reason, if I unplug connector 2, unplug these 3, and that's my ESC off. I do have these with color codes, just so I know which way I had them wired in the first place. That goes back in. For the battery power, as I said, I'm using a Ryobi battery with inline fuse. And it's a switched Ryobi there as well. Connect those up. Final thing for me, because I'm using Padawan, is I take the 5 volts and ground from here and plug them into the 5 volt and ground on the Arduino, and then the signal wire goes to pin 45 for the right leg and 44 for the left leg. And plug in my dongle. Now when I power this up, we should get a blue light, and I've got lights on my Arduino which show they're powered as well. So there we go, that's my motor running. But I'm getting ahead of myself now. Just before I go over to the programming of the ESCs and the Arduino, I'll just show this image representing the wiring that I've done on the motors. You can see the motor to ESC wiring is there, all color coded. As I said, the white wire is not connected because it is a temperature sensor, which these motors don't actually have. And the blue fine wire from the motor becomes the orange wire going into the ESC. Going to the Arduino, we've got 2 ground wires and 2 control wires. From the left foot, we've got the white wire going to pin 44, and from the right foot, we've got the white wire going to pin 45. Power into the ESCs, I'm using the 18 volt Ryobis, but anything up to 24 volts. And make sure that you do have a inline fuse for your power going in, and use a common ground as well. Okay, so moving on to the Padawan software itself, I've been working with Steve over at Imperial Light and Magic. And if you go to his GitHub, which is GitHub Imperial L and M, this repository, Padawan360 Mega Maestro DY-SV5W, using the newer DY-SV5W audio player, which Steve has talked about at a couple of drinks and droids, things like that. So if we go into here, you'll see there's two different sketches. The second one has PWM written here. This one I've modified for the PWM control of the hub motors. So looking at this code, you can download it, program it onto your Arduino ADK or your Mega with the shield. I will actually pull up the Arduino sketch itself so I can show you. This is effectively, I've just copied it into an Arduino, and I'll go through and show you the changes that I've made to the software. Lines 49 through to 62. Initially, we are defining whether we are using the Sabertooth serial or the individual ESC for the PWM hub motors. If you're using the old style Mark III motors and Sabertooth controller, set this to 0. Obviously, we're here to talk about the hub motors, so set it to 1. Now, if that is defined as 1, it then runs through this software here. So it's defining the output pins from the Arduino, pin 44 for the left motor, pin 45 for the right motor. Next, do you need to reverse the rotation of your motors? You can do that within the ESC software, but if you've forgotten to do that, or you get to this point and you find out that one of your motors is running in reverse, then you just change this from a 1 to a 0 or 0 to a 1. We have some variables here which we're just really setting start values for, and then the calibration speed. As I said, in the ESC programming, we need to be able to run the motors at full speed for calibration of the control sticks. Next, as with the Sabertooth, you're changing the speeds. So these are your 3 speeds. I would suggest not going above 50. 127, way too fast. 50 is a nice fast walking pace. If you're confident with your driving abilities faster than that, go a little bit higher, but definitely do not go up to 127. While I was doing these changes, I also found that the ramping of the speed wasn't working correctly on the Sabertooth or on the hub motors. I have changed the software slightly, so I would put the ramping interval down to 2, but I'd leave this ramping delay 200 milliseconds. I'm just going to pause the video again and say that the Arduino changes I've talked about so far are the variables that an end user can change for the speed, the wheel direction, etc. Moving on from here, the rest of the modifications I'm talking about are the changes I made to the software, which shouldn't be user changeable. Obviously, if you find an error, find a better way of doing things, then feel free to change it, but you will need to know what you're doing there. If you aren't interested in that in-depth review of the software, then you can jump ahead to the timestamp I give below. Lines 206 to 209, if you have the hub motors, then we're treating these signals as servo signals going out. 0 is full reverse, 90 degrees is stopped, and then 180 degrees would be full forward. You'll notice in a few places I also have this if foot controller equals 0, then it does something with the Sabertooth. So the reason for that is if I've defined the foot controller as 1, then when it compiles the software, it will just totally ignore this. It won't even go into the memory of the Arduino. And vice versa, if I have the foot controller set to 0, it doesn't even look at this for the compilation. But this is just setting initial conditions, stops your feet to begin with. Obviously, you want to be started at a standstill. If your Xbox controller loses connection at all, then stops your feet. That's part of the MOT process in the UK. You have to go to a safe condition if your controller loses connection. The next code changes I've made are down at line 679. For the Sabertooth foot controller, I've made some modifications primarily around this ramping section of code, which I've feel wasn't working correctly. Hopefully it is now. Then we move down to 728, and I've added this code for the hub foot controllers. So initially reads the forward, reverse, left and right stick values. If you have all of the triggers and corner buttons pressed on the controller, then it goes into calibration mode, and that will actually make the drive speed 127, full forward, full reverse. Otherwise, it will just use the standard speed. And it then calls this subroutine mix hub drive with variables for the stick positions and also the drive speed, whether you're in drive speed 1, 2, 3, or calibration speed of 127. If you are in automation mode, as soon as you move your stick out of the dead zone, it is going to switch off automation mode. That's to stop any issues with the delays used in the automation mode, stopping the immediate control of the droid. So we'll have a look at this mix hub drive subroutine. So this mix hub drive, it's inspired by Nightshade's shadow code. They've had PWM control in there for hub motors for a long time. So they've done this work ahead of me, and I really appreciate the help they've given us. First thing we do is we check, are we in the dead zone? If we are in the dead zone, do some stuff for the ramping. That's effectively what this is for. So if either axis of the drive stick, forward, back, left or right, are outside of the dead zone, then it's going to map those positions to a value. So the Y stick, it's taking the stick value, and that is on the Xbox between -3268 and +3267, and it's going to map that to -100 to 100. It's just making the calculations a bit easier by making it plus and minus 100. This next area is for the ramping of your speed, and we also map the X position, so left and right, to a plus and minus 100. Now the formula that I'm using to create the speeds for the left foot and the right foot are as follows. We'll take the forward back of the stick, so the velocity of the stick, and we will take away the left and right movement times 100%. So the formula that I'm using for the left and right feet to calculate the speed that they need to be going at is we take the throttle value, so that will be a positive or negative depending whether you're going forwards or backwards, and then we subtract the left and right times by this turn speed divided by 100. And what that means is that if you're turning left, then it will slow down your left foot very slightly and speed up your right foot. Finally, we put these values into the 0, 90, 180 values for forward and reverse. That's so that the servo library can use it. And of course, it's deciding whether that value should be positive, negative, and a bit of ramping, and that's it. And that's all the code changes. It wasn't a huge number of code changes, and the formula for the foot speeds, it's a very simplistic formula. There may be improvements that people can do to that, but I've been driving it at a couple of cons and it seems to work really well. As normal, you would compile this and program it into your Arduino ADK or your Arduino Mega with Shield. If you are using an ADK, make sure you have ADK selected up here, not just the standard Arduino Mega. I've made that mistake. And that's pretty much it. You do need to program this into your Arduino before you program the ESCs. That is just so that you can calibrate the controller with the ESC. So that covers pretty much everything I have to say on these hub motors. So hopefully that's useful for people, and let me know how you get on. So for programming the motor controller, you're going to need some software. And that software is available on this website, the VESCproject.com. And you will need to create a username and password in order to download the software. If you create that username and password, come down here. What you want is the VESC tool free. Add it to your cart, check out, costs nothing. You'll receive an email which will give you a download link. Once you download it, you then have a zip file which you open up and it gives you this screen. So looking at this screen, we will now program the controller. To program this, we will plug a USB cable in, and you do have to have the main power connected before it will connect to the USB. But plug in the USB, and it's immediately seen the COM port 21, so I'll connect to that. So for programming the motor controller using this VESC tool, what we will need to do is click on the Setup Motors FOC, that's Field Orientated Control. I believe that's the acronym anyway. It will pull up this window and ask if you want to load the default parameters. In this case, I'll say yes. So we're going to have a generic motor. I'm pretty much leaving all of the settings as defaults, unless I specifically tell you otherwise. It's I've selected the e-bike DD hub motor, and it just gives you a number of warnings as you go through here. Battery type, I've got a Ryobi lithium ion, 5-cell, 6 amp hour. So I've changed these settings already. You'll need to select your particular battery type, etc. Warning, it's direct drive, i.e. no gearbox on this motor. The wheel diameter, you need to tell it this as well, and you can't actually select it, you just need to delete, then add that in. Motor poles, leave as is. I'm just going to pause the video here for a second. Where I said that we would leave the number of poles as the default 14, we've actually done a bit more research recently and found that these motors are 20-pole motors, as you'll see in the image here of a motor which has had the side panel removed, exposing the winding and the magnets. If you count around the outside, you will see there are 20 magnets, therefore 20 poles. And now back to the rest of the programming video. And the temperature sensor, there is none. And what we'll do now is we'll run detection of the motor. This will move the motors, so make sure that you have your foot facing up the way or droid on its side or something. You don't want this sitting on the floor when you do it, otherwise your droid will move. So we will detect all motors over the CAN bus. It makes some weird noises as well, so don't panic about that. There we go, we get a bit of movement. And again, this is detecting all of the poles of the motor, the hall sensors. It's making various measurements of the resistance and impedance of the motor. And gives you the results at the end. So it's detected the hall sensors, no temperature compensation, and some various electrical parameters. Click on OK. It now asks you if you want the motor to be reversed or not in direction. In this case, I know that I do need it reversed just for my control system, and then click on Finish. So we've set up all of the parameters for the motor, and you can go through all of these and have a look at them. But I won't be doing that here. But we need to set up the controller now. Whether it's RC or Padawan or whatever control system you're using, you need to set up your controller so that it knows the maximum and minimum throw of your control stick and where the dead zone is, etc. So set up the input. Comes up with this input setup wizard. Click on next. So ppm. I've reduced the deadband down to 3% because I found the deadband in the ESC was causing some issues with the deadband within the Padawan code. Now, you see when I move the stick here, it's only moving very slightly, and that's because I have it on a speed setting less than 100%. 100% is the 127 signal ppm. Obviously, 127 forward, 127 backwards. What I've done is I programmed the Arduino so that if I hold all 4 of these buttons, it's now at maximum speed possible. And if I move the stick around, you can see that it's sensing the limits. So after I've wiggled the stick around a bit and brought it back to the center, click on apply, and it writes that software. Go to next, and we want the control type to be duty cycle. Write the configuration to the VESC. Click on next, click on finish, and now this should work. Forward, backwards. That's on speed 1, speed 2, and speed 3. Just to show you how fast the motors can run, I will hold all 4 buttons down. Don't do this when you've got it on your droid, you will break something. And go forward. As I say, you will break your droid if you do that. So that's the programming of the ESC. That's now programmed. I'd run through the same process again for the left foot, and then that would give me both ESCs, both motors configured and ready to go. So that's now covered the wiring, the Arduino code, and the programming of the ESCs. That's pretty much everything that you need to get the hub motors working with the Mark IV feet. Obviously, if you're using RC, then you'll need to make some modifications to the wiring and the method of calibrating the ESCs to your controller and how you have your transmitter set up, but that should be achievable quite easily. I'll just quickly show you how I have the ESCs mounted in my battery boxes, and then that will be the end of the video. And for anyone that's interested in how I have the ESC mounted, this is the view here. So I have the short cable coming from the hub motor, and this board here was created by another member of the Facebook group, and I've just used that for mounting the ESC. Just tuck the wires in. Obviously, when you're running, make sure that you have the cables all cable tied and out of the way of any moving part, which is why I have cable ties here. And then that just pops back onto your droid. So there we go. I'll just put this wiring diagram back up at the end here, just so that it's easy to find within the video. You can just scroll to the end. And if you've made it to the end here, well, thank you for watching the whole video, and hope it's been useful for you. And I hope it will be useful for you for setting up your own hub drives. So that's me. I'll sign off now, and may the force be with you.